Right. So beta 1 hat is an estimator of beta 1. Beta 1 2 hat is an estimator of beta 2. Remember, beta 1 and beta 2, these are parameters. Okay. Beta 1 hat is an estimator. Beta 2 hat is an estimator of beta 2. They are totally different thing. Beta 1 hat is an estimator of beta 2. Don't mess these two things up. Okay. And then we said, what is an estimator? Estimator is like you have a random variable x with mean mu and variance sigma square. You really want to know mu, you really want to know sigma square. These are population parameters. Then there is no way to find mu. What do? You find x bar. What is x bar? X bar is a sample mean, which is summation xi over n. This x bar is an estimator of mu. You want to know mu, so you find x bar, which is an estimator of mu. And an x bar is also a random variable. So an estimator is nothing but a random variable. And you say if x is a random variable with mean mu and variance sigma square, x bar is also a random variable with a mean mu and variance sigma square over n. I asked you to show that in the exam. Most people did not care to do that. Anyways, so sample mean x bar is an estimator of mu. X bar is a random variable. Similarly, beta 2 hat is an estimator of beta 2. And you have used OLS method to find beta 2 hat. And the beta 2 hat is an estimator of beta 2. Obviously, beta 2 hat is a random variable. Don't forget this. Beta 2 hat is an estimator of beta 2, and beta 2 hat obviously is a random variable. Any estimator is a random variable. How did you get beta 2 hat? Used OLS estimation method to find beta 2 hat. Now, is beta 2 hat is a good estimator of beta 2? That is the question at hand. Is beta 2 hat? So we are focusing on beta 2 hat. You could do on beta 1 hat, but beta 2 hat is more important than beta 1 hat. So we are focusing on beta 2 hat. Is beta 2 hat a good estimator of beta 2? That's a valid question. Good, quote unquote. And what does it mean? Good. What good means? We will let you know in a while. But to be a good estimator, beta 2 hat, to be a good estimator of beta 2, the model should follow some assumptions. The model should follow some assumptions. Here is the model, okay? Y equals beta 1 plus beta 2 xi plus uy is the model. There will be some assumption on that. First assumption, that the model, the functional form is right. Functional form is right means if really it's a linear relationship between x and y, it has to be linear. If it's a nonlinear, square, quadratic, cubic, you have to write quadratic, cubic. So basically, when they say functional form is right, we assume that the model is linear in parameters. Linear in parameters. So here is a model which is linear in parameter as well as in variables. The power of beta 1 is 1, the power of beta 2 is 1. So it's linear in parameters. The power of y and x is also 1. So it's linear in variables. We need linearity in parameters. So here is a model. This is linear in variables, but this is not linear in parameters. You cannot estimate this by OLS. I mean, you can estimate, but you will not get good estimators. Okay, you will not get good estimate. Here is another one. Y square equals beta 1 plus beta 2 xi plus ui. This is not linear in variables, but this is linear in parameters. Can you do OLS on this? Yes, you can do OLS and you can get good estimators. How about this? Log of y equals beta 1 plus beta 2 xi plus ui. It's not linear in variables. Here is the log in y. But it's linear in parameters. Can you apply OLS, ordinary least square methods, to estimate beta 1 and beta 2? Yes. If you do that, will you get good estimators, estimates of beta 1 and beta 2? Yes. How about this? Log of y equals beta 1 plus beta 2 log of xi plus ui. Is it linear? It's not linear in variables, but it's linear in parameters. It's linear in beta 1 and beta 2. So you can apply OLS and you can get good estimators of beta 1 and beta 2. Yeah, we are recording. Aren't we? Yes. So now, before moving on, how do you explain beta 2 here in this model? Here. How do you explain beta 2? The slope of the model. Can anybody explain? Interpret beta 2? Hello? See, from now on, we will start doing the software, and then it will be more important for us to interpret than to derive. So how do you interpret beta 2 here in this model? Hello? Nobody can interpret the intercept and slope? Hello?
If we increase x, yes, Professor.
Yeah, yeah. Go ahead.
If we increase x by 1, by how much y will increase?
Y or on average Y? Did I
On
say on
average
average?
y.
Huh? If X increases by 1 unit, Y on average increases by beta 2 units. Yeah,
Unit.
because of this U. Because of this U, you are saying on average. But anyways, let's say U is not there for simplicity. There is a random term is not there. Then if X increases by 1 unit, Y increases by
beta 2 units.
Beta 2 units. But we know that there is a U, so it's an average result. So if you forget U, how do you get this beta 2? This is basically nothing but, isn't it? Huh? You have to understand this calculus. I hope you did intermicro with me and you have some memory from my intermicro.
Yes.
dy dx. Ignore U. So what is dy dx? Huh?
Beta 2.
Beta 2. Please ignore U for the time being for simplicity of our analysis. So dy dx, the very meaning of this derivative is if x increases by 1 unit, by how much y increases. Here, if you get beta 2, then it's beta 2. If you get 55, then it is 55, and so on. Please, I cannot emphasize more this meaning of derivative in our analysis. So when the interpretation of beta 2 comes from the calculus dy dx. Obviously there is U and it's like on average result. Now, any question about this derivative stuff? or you already know this thing? I hope you already know this thing. Okay. Do you? dydx. Everybody know how to interpret dydx in this class?
Yes, Professor. Yes, Professor.
Okay, I take it as an yes. So here, this is a model widely used.
Professor?
Basically, yes.
Sorry to interrupt. I
Yeah.
just had a query. In the second equation, like yi plus b1 plus b2 whole square.
Equals.
No. Is it supposed to be b2 whole square or is it supposed to be x1 whole square?
No, this is b2 square.
b2 square.
Yeah. So that's why it's nonlinear in what?
Parameters.
Parameters. It's linear in variables, but non-linear in parameters. The model has to be linear in parameters. You see, assumption? The model has to be linear in parameters in
Professor,
econometrics. Yeah.
Can you use numerical examples to explain this equation, the second equation? Numerical values?
What kind of numerical example you are looking at?
No, because but if we use numerical values for the second equation, so it's in place of beta 1 and beta 2, there is going to be numbers, right?
Numbers.
Professor.
Yeah.
But like for example, if it is beta 1 is 3, beta 2 is 9. So how are we gonna if the total equation is yi plus equals to 3 plus 9 xi plus ui.
So what
but
you are
it will
saying
be
is
like
what you are saying is yeah.
How is it non-linear? Like if you give beta whole square and beta 2, how is it non-linear?
No. I see your point. Okay. Yeah. If you look from maths point of view, it's not non-linear. Okay. True. But this is from OLS point of view. From OLS point of view, it's non-linear because if you estimate this, if you apply OLS method, obviously you will get some number here, won't you? That's what you are trying to say, okay? So you are saying if you get some numbers here, okay? You get some number here. Give me a number 5 here, okay? And what are you giving here? Hello?
9.
9. So this is like 5 plus 9 square xi, okay? Is it non-linear? No, it's linear. Actually, it's linear in variables. That's how linearity is defined. But for OLS, that's not an issue. For OLS, the issue is, can you estimate and get good results? So if you estimate this model, using OLS, what you get here is, you will not get, sorry, I'll go back to the number. You will get an estimate of 9 square, beta 2 square here. You will get an estimate of beta 2 square. You will not get beta 2 directly, okay? See, here, when you estimate this, this is a more deeper question you are asking. I'm not sure if you understand this here from now, just now. Here, if you estimate, you get beta 1 hat and beta 2 hat, okay? You use OLS principle. If you estimate this, you get beta 1 hat and beta 2 square hat. That is dangerous for OLS. That is, OLS is not giving you good results there. I'll explain that when we talk about good estimates, the properties of good estimates. But yeah, I accept that this is not, this is linear in variables. Only that OLS has an issue with this kind of square or something like that. OLS will not give good results. All right. So let me go back to our focus here. See, look at this model. Yeah, Prachi. Yeah, go ahead. Prachi, you want to say something? Hello? Hello, Prachi. You have to say something? All right, if not, let's go ahead. So right now, this is a deeper question. Really, when you say linear in econometrics, well as you are basically looking at linear in parameter. Parameters are not in other forms than in linear. So here, this is a model. These two models are most widely used. I have to proceed some. These two models are very widely used, and I guess you will have one example in the homework. So here is a log of y, and here is the log of x. Is it linear? Really, no, it's not linear. It's a non-linear. It's a logarithmic. But how about the parameters? The parameters are in linear. No square root, blah. So OLS, if you apply OLS, you can get beta 1 hat and beta 2 hat, and they will give you good estimators of beta 1 and beta 2. Now, if I ask, how do you interpret beta 2? Like here, how do you interpret beta 2 here? Versus how do you interpret beta 2 here? Anybody? Hello? Anyone?
So Professor, do we say if we increase ln x by $1, then on average ln y increases by?
True, that's true.
2?
But yeah, that's not wrong. That's true. You increase log x by 1, you need log y will increase by beta 2. But it has a more practical meaning. Very, very useful meaning. Have you heard of elasticity?
Yes, Professor.
Yes, Professor.
Okay. So what is the price elasticity of demand? Who can tell me in plain English? Price elasticity of demand.
The change in demand due to the change in price.
Say it again.
The change in demand due to the change in price.
Really? Then what is this? If this is price, this is quantity, then what is this? Let's say X is price, Y is quantity demanded. Then what is this? So if I write it like Q equals beta 1 plus beta 2 P, then what is beta 2? What is beta 2? Isn't it beta 2?
Yeah.
Is that elasticity? That's what you are saying. Change in Q due to change in P, dQ dP. What is elasticity? Anybody in this class can explain elasticity?
So Professor, it's percentage.
Who is speaking?
Raisa.
Raisa, yeah, go ahead.
So is it percentage change in quantity demanded by the due to percentage change in price?
Exactly. So if price increased by 1%, by what percent quantity demanded? Decreases. If price increases by 1%, by what percent quantity demanded decreases? It's not about units. It's a percentage. So, okay. So let's take this model here. So this is it that percentage change? No. How do I interpret this derivative? dq dp? Hello?
Change in quantity demanded due to change in.
No, say it in 1 unit.
Or if we increase price by 1 unit, then on average quantity demanded decreases by.
Yeah, on average because of this u. Okay. So we are ignoring u right now for simplicity only. So if P increased by 1 unit, Q increased by beta 2. Obviously, you will get a negative here. So that is not elasticity. Elasticity is percentage change in quantity due to percentage change in price. So if price increased by 1%, by what percent quantity demanded? It decreases. So let's put it here. So it's basically this. Is it? Is it? So Q here, P here. How do you interpret beta 2? 1 or 2 line of calculus will give you that. Can I write like this? If you do dq equals 0, because beta 1 is a parameter, it's not changing, it's a constant. Beta 2 multiplied by 1 over P divided by dp. Everybody with me here with this line? Do you have any question about this line? Huh? Hello?
Professor, where did you get 1?
1. Oh, what is this?
Ln Q.
So when you differentiate ln Q, what do you get?
1 by Q.
Huh?
1 by Q.
Yes, that's how.
Okay.
So 1 by Q dq, and this is 0. Beta 1 is a parameter, is a constant value, 0, plus beta 2 times 1 by P dp. Is it okay?
Professor, why did you multiply dq and dp?
It's a total differential. Huh? You haven't seen this?
Yes, Professor.
Huh? It's a very simple. Or I could do it directly from here.
Professor?
Yeah.
Oh, like, can you give us a reminder? Like, how did you get that? Like, from ln q to 1 by q to dq? As
How
a side
to?
reminder. Like, no. Like, from ln q, you got 1 by q into dq.
Mm-hmm.
Like, can you give us a side? Was there any formula or was there any side reminder?
Yeah, this. So basically, so what you this is called a total differential. Okay. So when you so what is dq? Dq means change in q. Okay. Change in q. Don't you write dq dp? How do you get
Yes.
dq dp? Huh? Change in q divided by change in p.
Right.
So okay. Let me write one digression here. Let's say y. Let's say y equals 5p. Okay. Then dy would be what? Huh? dy equals what? 5.
5.
5. Only 5 or 5 dp?
5 dp.
Huh?
5 dp.
5 dp. Or you could write it like this. dy dp equals one more line. dy dp equals what?
5.
5. Is that clear now? How you are getting this dy dp? Huh? Hello.
Yes, Professor.
Yes,
Yeah.
Professor.
So the same thing here. Digression. Same thing here. As this is not only q, this is what? Log of q. So what do you get? Because it's log, so you get 1 by q. Then change in q is here, dq, like dy here. Then you have beta 2, which is 5 here. Then 5 multiplied by, instead of dp, you get 1 by p dp. Why? Because this is a log of p. I hope you will understand this simple total differential. Then obviously, see, if you write dq, dq by q, is left hand side dq by q, is that true? Equals beta 2 multiplied by what? dp by p by e. Is it true? Now, what is beta 2 from here? Can you find beta 2 from here? I'll skip some few lines for you guys so you break your head. dq by q divided by what?
dp divided by p.
dp by p. Does it look like elasticity? No, not yet.
Yes, Professor.
Yeah, this is the so-called
Elasticity.
elasticity. So what is this price elasticity of quantity demanded? If you have quantity demanded on the left hand side, price on the right hand side, then this beta 2 is nothing but price elasticity of demand. First you need to digest this. This is one of the most widely used model, log and log. It's called a log-log form or double log form, where the interpretation of the slope is nothing but elasticity. So here, if this is a log q equals beta 1 plus beta 2 log of p, then beta 2 is price elasticity of quantity demanded, okay? P elasticity of q. If you have y there, x there, how do you interpret beta 2? Hello? If you have quantity demanded here, price there, what is beta 2? Beta 2 is price elasticity of quantity demanded. If you have x here, y there, what is beta 2? Hello?
X elasticity of Y.
Of y, exactly. X elasticity of y. And x can be anything, y can be anything. Let's say here y is yield, agricultural yield, okay? Like paddy, rice paddy, as agricultural yield, and x is rainfall. Then what is beta 2? If let's say this is the production of rice, y is the production of rice, x is the rainfall. What is better to? Hello? Someone? What is x? Rainfall. What is y? Output. Quantity produced. Quantity of rice produced. Yield of rice. Then how do we interpret better to? You have to tell this. Why? Yield of rice and x rainfall. How do you explain better to? Hello. Afra?
Is it the percentage change in the yield of rice due to the percentage change in rain?
Say it again.
The percentage change in the yield of rice due to the percentage change in rain.
Yeah. So if rainfall increases by?
1 unit, then the...
No, don't say unit, please.
Oh.
When you talk about elasticity, elasticity is unit free.
If rainfall increases by 1%, then by how many percent the yield of rice?
How many percent is here?
Why?
No, better 2%.
Better to.
Oh, sorry, better.
If rainfall increases by 1%, yield of rice increases by
Better 2%.
better 2%.
Better 2%.
So that is better 2 is rainfall elasticity of yield of rice. Rainfall elasticity of yield of rice. There will be many kind of elasticities. Don't think price elasticity of demand is the only elasticity on earth. There are many elasticities, and you have to, if you want to estimate elasticity directly, you use this kind of model, log model. So an interpretation is very different than a linear model like this. All right. So that is one you will see in your homework, I guess. Another one I will not tell you. You will find out like this. Log to the left-hand side, linear in the right-hand side. It's called a log lean model. Log lean model. Log on the left, linear on the right-hand side. Then better 2 will have another interpretation. You find out. You read the book. Your textbook has all the interpretation of these models. Okay, so for us, so now you are ready to submit your homework. You will do it in 3 days. You submit your homework. And so the model is correctly specified means basically you have to, if it's a linear model, you have to write the linear model. If it's in a quadratic, like x square, x cube, all this is you do in that way. If it's non-linear in parameter, forget about it. If there is a way to linearize it, you linearize it, or you don't want to estimate that part. It's not you will not get a good result. But when you have different models, which is manageable, like this model, log lean, or you have log model, then you know that the interpretation is different. In a log form, log left hand side, log right hand side, is this slope is nothing but the elasticity. Okay, so that is one. When they say a model is correctly specified, and three other meanings. This is not trivial. B is another. When you say the model is correctly specified, the model is correctly specified, that means all important independent variables are included in the model. So as I said in the last class, if this is a demand model, if it's a demand model, quantity demanded is a function of price, but you have to also include consumers' income, because that's a very important factor in determining quantity demanded. Also, maybe any close substitutes price should be included, and so on. You cannot omit any important variables from the model. If you omit, you will not get good results. Also, no irrelevant variables can be included in the set of independent set of independent variables. You cannot just dump a variable in the independent in the right hand side. You have to justify why you are adding a new variable in the model. If it's irrelevant, you cannot add that. So basically these three. One, the functional form has to be right. Basically, we are assuming it has to be linear in parameter. At least it has to be linear in parameter. Number two, all important variables should be included in the model, meaning in the right hand side in the set of independent variables, also called regressors. No relevant variables, no irrelevant variables can be included. You just cannot add any variable you feel like in the model. Believe me, people do that. People try many different variables. There is one article called "I have run a million regressions." Million regressions. What are they doing there? They're dumping all different types of variables in there. No, you cannot do that. You should not do that. You have to always go back to economic theory. You have to check what variables should be in the model, what variables should not be in the. If economic theory says this variable is important, like income in the demand function, you include demand. If in economic theory does not say that the price of the price of an input of a production process should not be in this model. Theory does not say anything in that line, so you should not include. If you want to include, you have to justify why you are including that variable in the model. The fourth is obvious measurement errors. So if you are measuring some variables but you are making mistakes in measuring, that will be an issue. So anyways, basically first three, functional form should be right. Whatever the actual functional form is, you have to include that model. Let's say you are talking about a cost function. What type of cost function do you know about? Do you know about cost functions? Did you do production, theory of production? In Intermicro? Hello? A lot of people left because of this clumsy thing. Anyways, I'll not go deep in there. You learn as you go. So the model has to be correctly specified, meaning the functional form is linear in parameter. And there are different types of models linear in parameters, and their interpretation of the parameters are also different. B is very important. You have to include all relevant variables, important variables, relevant important variables should be included, or else you will get very bad result. And irrelevant variables should not be included. And D is obviously, you should not make any mistakes when you are measuring the variables, demand, supply, prices, income, you should be correct in measuring those variables. Now, the actual other important ones, assumptions for all as estimators to be good estimators. Number one is error term. Here is error term, random term U. In the model, don't forget this U. This is a random variable U. This is a random variable and Y is also a random variable. Now, this variable, we will assume a lot of things on that variable. That is the most important variable in econometrics, U, even though we tend to ignore that U. U is the most important variable. It's in the model. Without that U, there is no econometric model. So that U is there. Now it's time to assume about U. What is U? U is a random variable. Now, let me show you what U is. Let me show this graph from one earlier class. Have you seen this graph? Remember our example? Income here, consumption expenditure on the vertical. So here you have all the income groups. They showed only 3, but there are many, 20 maybe, 80, 100, 120, 140, 160, and so on. These are the incomes, okay? And for one income level 80, how many values of Y are here? Many values of Y. In our example, I guess there was 5 income, for income 80, there were 5 families with 5 different weekly consumption and expenditure. You remember that? For one value of X, there were 5 different values of Y. There were 5 families, and their consumption level were different for each family. That means we said that for one value of X, Y has a distribution. Y has a distribution. That distribution has a mean, that distribution has a variance, and so on. If you recall that. Do you remember that? That income 80, the consumption expenditure was 55, 60, 65, 70, 75, so on?
Yes, Professor.
And then what is U? U is the difference between mean and other values of Y. U is Y minus expected value of Y. So let me write it here. You have to understand U first. U equals Y minus expected value of Y given X. So here, U, if you have this model, what is U? U is nothing but Y minus expected value of Y. Y, U equals if you remember this, or else it will be difficult for us to proceed. This is what you have. And expected value of Y is beta 1 plus beta 2 xi, the population regression line. So basically u is nothing but y minus expected value of y. So remember this, u equals y minus expected value of y. Then we go back to this line and here. So this is expected. All the values here on the line is expected value of y, population regression line. And y has a lot of values. Some of them are above, some of them are below. So what is u? U is y minus this mean, y minus this mean. Also, if any y value is below this, again y minus this mean, that at that time it will be negative. So u has some positive value, some negative value. Okay. What is the value of u at this point? Hello?
It's 65.
No, that is the value of y. U. U is y minus mean of y. U equals y minus mean of y. This is mean of y. All the values on this line is population regression line is mean of y. What is u? U is any y value, whether above this mean or below this mean. U means that y minus mean of y. So what is the value of u at this point?
0.
0, exactly. What is the value if y is here? Let's say y equals 149. Then what is the value of u? What is u?
84.
Y minus expected value of y. So if y is 149, what is the value of u?
84.
84.
149 minus
65.
65, exactly. If a value is 101, the u would be 101 minus 65. Let's say a value of y is 35 here. Then what is the value of u? 35 minus 65. Okay.
30 minus
Whatever the
30.
value. So you know that now u is nothing but y minus mean of y. So if y has a distribution, corresponding u values had the same distribution. Okay. What is the mean of u then? Here is the assumption. So once again, let's I'll go back and forth to this too. Here, assumption number 1. Expected value of u given x is 0. If you understand one, then you'll understand the other ones. So what they're saying is this u actually is nothing but y minus mean of y. If u is y minus mean of y, then here when x equals 80, y has, let's say, 5 values, then you also have 5 values. And then if 5 values of y have probabilities assigned, then 5 u values have the same probability assigned. Then the expected value of y is 65. Expected value of u is 0. Mean of u is 0. So number 1, they are saying when x equals 80, y has 5 values. That means u has also 5 values. because u is nothing but y minus mean of y. Mean is already 65. So 5 y values are giving you 5 u values, and that means if y is a random variable, u is also a random variable. And what is the mean of u? We know the mean of y. Mean of y here is 65. Mean of u will be 0. So assumption number 1 is saying when x equals 80, mean of u equals what? Huh? What is the mean of u?
0.
0.
If x equals 140, what is the mean of u?
0.
0. If x equals 120, what is the mean of u?
0.
Let's say you have a sample of 30. So you have 30 values of x and you have 30 u's. Okay. Each u distribution, each value of x is giving you a distribution of u. And what is the mean of that distribution u? 0. This is very weird, but this is what you should know, that all distributions of u, the mean of u here when x equals 80 is 0. The mean of u here when x equals 140 is still 0. The mean of u here when x equals 120 is 0. So in our example, at the first table we showed you, very big table where x has like 20 values, 80, 100, 110, 120, 140, 160, and up to 220. Each x corresponding to that, there is a distribution of u. And expected value of each distribution of u is 0. That is the assumption, very strong assumption. But without that assumption, OLS will not give good results. So one thing, expected value of u is 0. Now, again, another issue is, if it's a random variable, it has a mean, it has a what? Variance. How about the variance of u? They are saying variance of u. How many, if for our example, let's say there are 20 values of x starting from 80 and 100 and 120 and so on. There are 20 values of x. Then you have 20 distributions of u. The mean of each distribution of u is 0. The variance of each distribution of u is what?
Sigma square.
A constant, basically saying a same value. Same. Let's say sigma square equals 25. What is it saying? It's saying the first u distribution when x equals 80, the variance is 25. When x equals 100, the variance of u, there is another distribution of u. What is the variance of that distribution? 25.
25.
Let's say another one, x equals 140. The variance of that u distribution is also 25. So all the u distributions are basically like, the identical. They exactly look like same. Their mean is 0, their variance is same value. We are calling it sigma square. Basically saying it's a constant value and it's same for each of the distribution. So if u distribution for when x equals 80 and distribution of u when x equals 140, Can you tell which one is what? Is there any difference between these two? Huh? Their mean is same. Their variance is same. Is there a difference? Hello? Why are you keeping quiet? They exactly look like each other. They are called identical. Very interesting. They are like twins, identical twins. U1, first distribution, U2, second distribution, U15, 15th distribution. They all are identical. Their mean is 0, their variance is same constant value. How about their covariance? Covariance is telling you whether one is dependent on another. The covariance is 0. That means they do not depend on each other. They are independent. See, so it's a very weird assumptions. People criticize these assumptions. The U distributions are with mean 0, variance, sigma square, and their covariance between any two U distributions. The covariance is 0, meaning one U distribution is not dependent on another U distribution. So covariance between U1 and U2 is 0. U1 and U15 is still 0. U2 and U19 is 0. No two U distributions are related to each other. Assumptions 2 to 4. U is IIT. Can you see what I wrote here? U is? Hello? Are you with me here? Can you see what I'm writing here? Hello?
Yes, Professor.
Yes,
So,
Professor.
don't forget this term here. In econometrics, U is IID. IID means independently, identically distributed. Assumption 2 to 4. These three assumptions are telling you this, that U distributions are identical, but they are independent to each other. So they are called IID, independently, identically distributed. Mean 0, variance a constant value. Call it conventionally, we're calling it sigma square. This assumption is a very strong assumption, but OLS depends heavily on these assumptions, and you will see that the rest of the econometrics, after a while, obviously beyond some of them are beyond our syllabus, you will see that just examining these assumptions, are the assumptions right? If yes, good. If not, then what happens? That kind of questions will be asked always. So what are the assumptions? Assumptions, these three assumptions are on U. That U distribution. With one X value, there is a U distribution. If another X value, there is another U distribution. So these are like, if in our example, 20 X values, so 20 U distributions. Interestingly, and not very reliable, not very reasonable assumptions. The assumption about use are they are identical. They are like identical twins, exactly same. Mean 0, variance sigma square. So they are identical. However, they are not related with each other. It looks like two twins. They are this twin. They are exactly same, but we are saying no, they are not related. So that is the assumption about use. And assumption number 5 is another strong assumption. It's just saying the X values like 80, 100, 120, 140, and so on. Those X values will remain same from sample to sample. So you collect a sample. What are the X values you are using? 80, 100, 120. I collect another sample. X values will be same, 80, 100, 120, and so on. Y values will be different because for one X value, you will have a Y distribution. So you will get a value from that distribution. But X values will be same from sample to sample. I'll go over it again. These are 5 assumptions only. There are many assumptions, but I picked only 5 most important ones. First thing is the model is correctly specified. Basically trying to say it's linear. More importantly is linear in parameters. It cannot be linear, non-linear in parameters. If parameters are in non-linear form, you cannot do OLS. If you see non-linear form in parameters, you try to linearize it. If not, you say no, it's not. OLS cannot be applied. OLS cannot give you good results. But then when you say linear in parameters, then you can say, how about in variables? In variables, it can be non-linear. That is allowed. That OLS can handle that. OLS can give good results, even if with non-linear in variables. So two important models in non-linear variable, but linear in parameter is one, this left-hand side logarithmic. Another one is both hand side logarithm. I explained the slope coefficient here. I interpret. I said this is elasticity. Here you find what beta 2 is when you say log on the left hand side, linear on the right hand side. So you do that. So that is one criteria for correctly specified model. Other criteria are one, all important explanatory variables, the variables in the independent variables, you have to include in the model. I remember last year maybe, one student was doing something like growth and religion. So she put growth of the economy on the left hand side and religion on the right hand side, and she did all the regression. That is invalid. Any econometrician will dump that, will throw it in the trash can. He'll say growth depends on many other important variables like investment. What else? Did you do any growth theories? Did you do intermacro? Hello?
Yes, Professor.
So did you do solo growth model?
Yes, Professor.
Growth depends on what? Transition and steady state. Obviously, you have to include investment in the transition. Also, you have to include, say, human capital, like education. These are the variables you have to include. Then obviously you want to include religion, you do. But only with religion, you cannot do a model, growth model, only with religion or only with race. you have to include important variables that theory says important. Then you can add others, justify other variables. So all important variables have to be included in the model, and no irrelevant variables should be included. And measurement errors you try to avoid, sometimes is unavoidable. Then 3 assumptions. Actually, these also involve U, but let's say explicit 2, 3, 4 is saying each U distribution has a mean 0. It's population mean, not sample mean. And population variance of U, variance of each U distribution will be a constant value, same constant value for each distribution. And then they say any two U distributions are not related. Their covariance is 0. Then that's called an IID. U is an IID, independently identically distributed, also called white noise. Also called what? White noise. Meaning harmless. The U is just a noise. It's not noise. Noise. Is the spelling right? White noise? No. Noise. What is the spelling? Yeah, here. White noise. White noise means it just is creating some noise, but which is harmless. So U is identically, independently distributed, which means 0 variance sigma square. And then final one, that X values, the values of independent variable, those values remain same from one sample to another sample. They cannot change. They are all the same from each sample to another sample. So as I said, if I collect a sample, X values will be same, like 80, 100, 120, 140, and so on. Y values will be different from your sample to my sample to other sample, but X values remain the same. It's called X is non-stochastic. X is not a random variable. Is fixed from sample to sample. So these 5, and one more, not now, we don't need the 6th one. When we need the 6th assumption, we will let you know. For now, these 5 assumptions, if 5 assumptions are satisfied, then you can get good estimators of if assumptions one, 2, 5 are satisfied, then OLS estimator meters such as beta 2 hat. So we are focusing on beta 2 hat, so it's a beta 2 hat. Can anybody read this for me? Last line. Can somebody read it for me?
Professor?
Yeah.
Okay, I'm going to read. If assumptions 1 to 5 are satisfied, then OLS estimators such as beta 2 are blue.
Blue, yes. What do you mean by blue? Not blue moon. Did you see blue moon?
Professor, is blue mean best linear unbiased
Exactly.
estimator?
Yeah. This is called best linear unbiased. Gauss-Markov theorem, unbiased estimators. OLS estimators are the best linear unbiased estimators, and we'll explain in the next class what it means, best linear unbiased. So it's basically saying is the best among all linear unbiased estimators. Best among all linear unbiased estimators, which are good properties, and one by one we will try to explain. Meaning best among all linear unbiased estimators. So once again, here we know how to find beta 1 head and beta 2 head using OLS principle, minimizing residual sum of squares. Remember, minimizing residual sum of squares, you get OLS estimators. And then we know we did one example with your calculator and Excel sheet and all this. Then he said, are they good? Are they good enough to represent beta 1 and beta 2 population parameters, which we don't know, nobody knows? Then he said, if they will be good, quote unquote, they will be good if 5 assumptions are actually more, but for now, let's talk about 5. 5 assumptions are satisfied. Assumption number 1, the model is correctly specified. Basically saying functional form is right, its model is linear in parameters. Number 2 is all important variables are included in the model. You cannot ignore when you are doing a demand function, you cannot ignore the income of the consumer or price of the close substitutes or price of the close complements and so on. And irrelevant variables should not be included, even though people do that a lot. You will know why later on. And measurement errors you try to avoid. Then assumptions regarding U. As saying this U is a random variable. Area has a distribution. How many distributions you have? The many X values you have, that many U distribution you have. If you have 20 X values, you have 20 U distributions. And each distribution has a mean, which is 0. Each distribution has a variance, which is a constant number. It's the same for each of the U distribution. So these U distributions are basically identical. They look exactly same to each other. However, they are not related. That's a crazy thing to say, that two people are exactly same, but no, you are not twins, you are not even cousins. You don't know each other. You are totally independent of each other. That is the covariance thing, is making sure covariance is 0, making sure that they are not related. And together, assumption 2 to 4 is saying that U is identically and independently distributed with mean 0 and variance sigma square, which is a white noise. And also the X values, they are not random. They are same, exactly same from sample to sample. With these 5 assumptions satisfied, it can be shown that OLS estimators are blue, meaning OLS estimator, and OLS estimator is the best among, if you compare between all unbiased, linear unbiased estimators, you will see that OLS is the best. Now, in the next class, we will explain what unbiased means, what best means, what linear means. And we will not gonna prove much. Proving take long calculation. We'll prove some easy ones, like say unbiasedness or linearity. We can prove. Best is a long proof. I'll just let you know what that means. Try to make sense of what it means, and then we will move on to the software. So by the way, you download the whole folder, okay? You don't have to install Stata. You just can download it in your either on the in any drive, in D drive, E drive, or C drive, anywhere. You just copy paste the folder and you can run from there. That is the good thing about Stata. So download it because pretty soon we'll start doing the software, and then you will have a lot of fun. And you will see that how easy it's to run regression and do all the research. Yeah.
Hello, Professor.
Yeah.
Professor, when I open, there are like so many files, like
Yeah.
utilities.
Yeah,
then
you have to combine all of them in a folder, and you need all files. If Campus was open, I would have given my flash drive to you, so you could just copy from the flash drive. But now it's not possible. If you can download
But
everything, you can.
instead of like joining all of the folders, can we like open one by one and then?
Whatever way you can do. I am not an expert. Okay, this is a unusual situation, so we try to share with you. In other time, I just give the flash drive to students and they copy it from there.
And Professor, I can see 4 folders for one thing, like the state.
Yeah, please, I don't know how to do that. Okay, so I cannot solve that issue. You can talk to Nusaiba. She might have idea. Okay, I don't know how to do that. But what I know is if you don't copy and paste all the files, the program does not run. That is the problem. The whole goal is to run the program. If you can run the program, then you can practice, or else I don't know what to do.
Where we have to run this program?
We'll do all in each class. We'll do this. We'll work with data.
Okay, Professor.
Just yeah. So next class maybe not, but next week. From next week, we will every day we will do some. We'll exercise. Do some exercise. We'll practice with data. That's the whole point. You do econometrics, you do all theory. Then can you handle data? That is the whole point. If you have data set, can you run the regression? Can you?
Professor.
Yeah. Yeah.
Hello.
Yes. Yeah, I can hear you.
Hello, Professor.
Yeah, I can.